All right, welcome to another tutorial. Today we are going to be adding very simple particle effects to the original Contro demo from the gun shooting tutorial. And we're going to be sticking with C again for the programming language today, so I'll be using the C version of Contro. And just to show you where we were at when we left off, I basically had a keyboard controlled guy that could shoot an enemy on the right, and of course that's basically what I had. So what I'd like to do is this is very NES style, if you could even call it that, graphics. So a lot of things that are commonly done with indie game development these days is people typically will take, you know, the retro style of games, and they will add something to it to make it, you know, seem like more modern than it really is, and almost kind of mix the two modern and non-modern worlds. And commonly one of the ways to do that is to add particles, which, you know, would be very difficult to do on like an old Nintendo, to a retro style game. So what I'm going to go ahead and do here is just add essentially red particles to sprout out of the enemy when he dies to kind of simulate, I guess, kind of like a blood splatter or something like that. And I'm going to show you guys how something like that would work. Very limited particle effects, but it'll at least get you started. So for starters, sometimes in older style games, people will just use pixels for the particles, but I'd like to use images because they're more versatile. So what we're going to go ahead and do here is pull up the folder that contains the Contro assets and just make a very simple particle image. So I'm going to go ahead and pull up Pixelmator here, which is my art program of choice these days. And I'm going to create a new image, and it's going to be 32 by 32. Got it. I don't want to spend too much time on this. This isn't really what the tutorial is for. So there we go. So I'm going to go ahead and export this thing out. I'm going to load it into the game. So I'm going to go ahead and just create another STL texture for this. And I'm going to follow the lead of how I loaded the bullet to load the particle texture. Particle texture from particle, I'm assuming that was a surface, so I got to declare a surface up above. I don't see where I do that. Oh, here it is. So I'm just loading the particle here using STL image. And of course, when the program quits, I'm going to go ahead and get rid of that texture as well. So let's just run it, make sure we're good. Everything seems to be fine. There's a warning here, and that's probably because that's totally wrong. It should have been the texture. Okay, so we have our particle loaded. Let me just... Yeah, so let's move on to the data structure part of this. This is kind of the best way to keep particles organized. So we have a struct for man. We have a struct or an object type for bullet. I'm going to go ahead and create one for particle. And of course, every particle will have an X and a Y. It's also going to have a delta, or another way to call it delta is velocity in either direction. And so that basically it can move in any possible direction. And it's going to have a life span. Yeah, it'll fade out over time, so I'm going to give it a life. And that'll be a float as well. Okay, so we have our particle. So the way this works is, much like we have multiple bullets in an array, we're going to go ahead and create an array of multiple particles. And I'm just going to give this a maximum. 1,000 was a lot for bullets, and it is for particles too. But it's a way for me to at least know that I'm not going to run out. And you know, when you're dealing with something as small as a struct of like 3 floats or 4 floats, 1,000 doesn't take up that much RAM anyway. So we start our array out. As I mentioned in the last video, or at least the last video that dealt with Contro, when you set an array equal to curly braces, it initializes it. And if you only put one item in there, and that item is 0 or null, it will fill the entire array with null, which is what I want to do. So I'm just taking a shortcut there, in case that looks weird to you. So we have our array of particles. Now there's a couple things I want to do here. This will be the first time we've actually used random, I think in like my entire tutorial series. So what I'm going to go ahead and do is, I believe, include standard lib.h, which is where I believe random lives, and I'm going to seed the random number generator. I think we also need something called time.h here. And what the random number generator will allow me to do is pick random numbers so that I can add some random variation to the way the particles behave. So let's go ahead and seed that probably before we do almost anything, probably right after SCL init. And the way you do that is you call srand to pass time, and then you pass 0 as the argument to time, and that seeds the random number generator. And that's been done. So now I can call rand and basically get random numbers all I want, and that's what I'm going to want to do. Now initially, all of the particles are not in use. However, I'm going to want to spawn some particles when I hit the enemy. And I probably want to have a function for that called void add particles. And we're going to basically give the particles an emission position. And that's probably all the information they're going to need, basically where the particle explosion is coming from. All the other parameters of how the particles behave, I'm going to hard code in this function, with the exception of a number that basically is the number of particles that I want to add. So much like when I add a bullet from my previous code, I basically want to add particles one at a time. So I'm going to find a free particle using the for loop. I do call that particles lowercase, right? Yep. So I want to find a free particle, and then once I found it, I basically have it as a particle that can be used. And then I essentially spawn the particle by creating the particle using malloc, just like I did with my bullet, and then initializing its parameters or its properties or its stuff. So if I found it, then I equals found, bullet sub I equals no longer bullets, this is particles. We malloc a size of a particle, and then we initialize it. Of course, we basically want its position to start out at EX and EY. All the particles are going to start out from the exact same position, but we're going to basically fountain them out in all these random different directions. So the thing that actually becomes quite random is really going to be the DX and the DY. So we want those to be randomly generated. I'm just going to pre-declare those right now, and I will initialize them to something in just a second. Now once the particle has been added, we definitely want to give it a life. The default life is going to be based off of frames. So let's say they go away after 60 frames, which will be 1 second roughly. So we'll set that equal to 60. Yes. Okay. So now we want to initialize the dx and dy. So one quick way to do that would be to set it equal to a call to rand. And what rand will do is actually give you a number all the way between 0 and some special called rand max. Now if I was to want to cut the range down, I could use this modulo trick, as you see a lot. For example, if I wanted a random number between 0 and 5, not including 5, 0 to 4, I could do that. Now, since rand goes to rand max automatically, what I can do is I can cast the return value of rand to float and then divide it by rand max, and basically that will allow me to get, with the best possible random distribution, a random number between the values of 0 and 1. So I'm going to go ahead and do that for dy as well. However, what we really would like is random values between -1 and +1. I think. It's actually probably going to be something closer to like -4 and +4 or something like that. As a matter of fact, I'm going to pass that as another argument called energy. And we'll multiply the -1, +1 range by energy. So in order to do that, basically all you have to do is subtract 0.5 from the value returned. And as I can see with my just quick LLDB testing here, if I was to get 1, it'd give me 0.5. If I was to get 0, it'd give me -0.5. So that'll give me the normalized range I'm looking for. So I'm going to go ahead and do that to both dx and dy. I think I might have just made a mistake. There we go. And then at the end of all this, I multiply the end result by energy. which basically is kind of a stupid name for the velocity, the maximum possible velocity of one of these particles. So once I have that in place, I basically have almost everything I need. So this code right here, when I call add particles, will actually generate just one particle. I'd like to do this multiple times, and the way I'm going to handle that is to wrap this whole thing around a for loop. So now I will basically add the number of particles to the game that I call for the arguments, based off of num particles, which is an argument. So if this compiles, which it does, I am ready to go. So there's one more function I want to add. Right now I basically have a function that adds the particles. I need one that's going to process them. So I'm just going to have process particles here. And what this is going to do is loop through all my particles that are in existence and process them. I believe I have something around here for the bullets that does that in my processing code somewhere in this frickin' thing. In update logic, here we go. It's very simple. So I don't need to do, one of the nice things about particles is typically they're considered harmless things, so I'm not going to have any interaction between the particles, collision detection, anything like that. They're basically just going to move around the screen until their life is expired, and then I'm going to remove them from the game. So the way this works is by processing the particles, I iterate through the array of all the particles. If a particle has been defined, which means its pointer is not null, I then am going to add to it position its current velocity, which will update it to move in the direction that I've determined it should go. And I'm going to negate its life by 1. And if the life happens to be out, that'll mark the particle for deletion, which basically means I'm going to free the thing and I'm going to set it back to null, so it's basically marked as unused. Okay. Just realized I probably messed this up during the last tutorial. Or no, I didn't. Okay. If particles. Just want to make sure I give the memory back for the particles as well. Okay. What line is that? So we just about have everything that we want here. However, the major difference between particles and bullets is that the bullets I were assuming to be moving so fast that they were not affected by gravity. I do want the particles to be affected by gravity. So very much in the way that I have the man jumping and his dy gets offset by gravity, I'm going to do the same thing to the bullets dy as well. So I'm just looking for where in the code I basically do that. Apparently I don't define gravity. So I put gravity here. It looks like that is defined as a constant, which I'm going to pull out and sharp define it up here. So there's our gravity. This gravity might be too strong for the particles, but we'll see. Sometimes you can fudge it and use different gravity constants, depending on what you're simulating. After all, it is a game. It doesn't have to be accurate. So for now, though, I'm going to see what happens if we use the same gravity constant I used for jumping. Particles I dy plus equals gravity. I think I might have screwed up. No, I didn't. Okay. So there's my gravity. I'm just keeping track on what I'm doing here. I think we're okay. I think the only thing I have to do now is basically call process particles from update logic. So I'm just going to go ahead and call this right here. And last but not least, I think I just have to call add particles when the guy gets shot based off of the position of where he is. So here's where the simple collision detection occurs, where I basically say the guy is not alive. So I'm just basically going to put an if statement around this. It basically says if he was alive in the first place. I don't want to set a bunch of particles when he's already dead. And then I'm going to basically have a function called add particles, and that's going to be based off of the bullet's position. I believe the next argument was called energy. And the number of particles I want to emit, which in this case is going to be 100. And I just realized this isn't going to do anything, by the way, because I don't have any code to draw the particles yet. So I'm just going to quickly just put that right in line in my draw or in my render function, which basically is going to be very similar to the bullets code. It's just basically going to loop max particles. Particles. Come on. All right. Particle texture. 8 by 8 is wrong. In this case, I believe our particles were 32 by 32. Of course, a bug in Mac OS makes it so the damn thing doesn't show up. All right, 32 by 32. This, if I didn't make any mistakes, should show the particle fountain. So as you can see, they come up, but the gravity is way too strong. So basically, they immediately fall down like crazy fast. So what I'm going to go ahead and do is simulate wind resistance or drag by basically dampening the gravity. All right. We can also see that the life is not long enough. And we can also see that I don't assign dx properly, or dy properly. I had a bug in here. I was putting dx. So if I double the life, that looks a lot more like a particle explosion. It's a little too big for this game. I could easily fix that just by taking the 32 by 32 and halving it to 16 by 16. In real life, of course, I would shrink the asset itself. So there he basically is, exploding into particles along with the sprite animation that I had before. And of course, I can tweak the particle settings so that I could basically, instead of having everything be a uniform explosion, maybe I could say that Y should be more likely to explode in the up direction. So maybe in that case I would subtract 0.5 from the entire Y direction, so they would mostly explode upwards. Of course, if I was going to do that, I probably would do that before I multiplied my energy. So maybe something like this. See, so now they mostly go up. Of course, I'm going to make the life a lot longer so they don't disappear on me. So that's basically it. Now, this is not, the most perfect particle tutorial in the world, but it's definitely enough to get you started so that if you were going to do something like this in a game, you could. And what's really neat is, you could do a particle fountain where if you wanted to, even though it wouldn't make a lot of sense, I could actually, once the guy is dead, I could set some crazy flag. Well, I guess alive.0 would be it, that basically says if the enemy is not alive. Do I have a time or a T anywhere here? Global time? Doesn't look like I do. Well, let me just set that here. Oh, there it is, global time. So if I had a global time here, which I do, I could basically say after he's been killed, every 6 frames, spawn more particles, and this would basically create almost like an infinite particle fountain until I run out of particles, because now I don't know if 1,000 is enough. And of course, this would be from the position of where the enemy last was. I don't know if the enemy is a pointer or not. I think he's not, so I think I do this. This is going to look ridiculous, but it's all part of having fun. There we go. It's just a particle fountain going nuts until it runs out of particles, which it seriously did. And then, of course, once the particles all come back, it does it. All right, so basically, there you guys have it. That is how to do wild particle effects, or at least get you started on particle effects programming in C. for games. Hope you guys enjoyed it. Stay tuned for another tutorial. Bye.